Hello and welcome. In the last video, we had a discussion about the write method, set method, get method, and get mirrored value method. In this video, I will be talking about the front door and back door access. Okay, so from front door access, we'll try to understand write and read methods. Already we had a discussion about write. Now we'll try to understand the read method. So this read is used to read the data from the hardware register which we have written using write method onto the hardware register. And then this remaining four methods, update, mirror, predict, and randomize, we'll see in the next video. After write and read front door method, we'll try to explore about the backdoor access methods like poke and peek. So this poke method is similar to write method. So here in backdoor access, actually we are not considering the agent. We are completely bypassing the agent and directly providing the HDL path and HDL path slice. By using those two methods, we'll writing the data which we want to write into the hardware register using this poke and peek method. So peek is similar to read method. So we are completely bypassing the agent in the backdoor access. Just we are providing the path of the register which is there in the DUT. Okay. Remember already I had a discussion in the first video that why backdoor access is faster compared to the front door access. And in that video, I told you that the backdoor access, in the backdoor access, we are completely bypassing the agent. And completely bypassing agent means we are providing the path of the hardware register, and it will not consume any number of simulation clock cycles. So if you see and analyze the result after this peek and poke, you will find it will consume 0 time. Hence, the backdoor access is faster compared to the front door access. That question we will try to understand here with the practical example. Okay, let me show you the front door write and read first. Okay, so directly I will jump to the code. All the things are same. The driver, sequencer, transaction, agent, all the classes are same. The register class, the register block, all the things are same as we discussed in the last video. Now here just I am going to explain you the register sequence. So this register sequence content is also same till this body. So in the body already we discussed write register sequence which is extending from UVM sequence, this factory registration micro, object details factory registration micro, an instance of a register block and its default constructor with one argument. Now in the body we have to define the field status which is of type UVM status and the two variables to store desired value and mirrored value. The size should be same as the size of the hardware register. Okay, so the hardware register size is 8 bits, so 7 down to 0 for these two variables. Okay. This readout is used to store the value which we are going to read from the hardware register. Okay. Now let me show you the methods. So front door write method is there, as you can see over here. Already we discussed, we have to put the syntax for this. Let me show you the literature contained for that first. So this write method already we discussed. It is used to write the value which we are specifying in the parenthesis to the hardware register, DUT register. Okay. And the syntax for that is we have to provide the status and the value which we want to write into the hardware register. And as you can see, the third argument is a path. So if you are not providing, it will take a default path, but it is always good if you are using front door method, we can provide the third argument like the UVM front door. Okay, let me explain you with the help of this code. So register block instance dot register instance dot write within parenthesis the status, the value which we want to write into the hardware register, and third one is the access UVM front door at back. Okay. and here just we are getting the desired value in this variable, desired value variable, using get method, and in the mirror value variable we are getting the mirrored value using get mirrored value. And after that we are printing a message like after write method, desired value and the mirrored value. Now the front door read, on the other hand, let me show you the content, the literature content for that. So as you can see, the read method is used to read and return the value from the DUT register. Okay. And the syntax for that is, first we have to provide the status. Okay, let me show you the code for that. So the syntax for that is register block instance dot register instance dot read is a method. Within parentheses we have to provide the status, then the variable in which we want to read the data from the hardware register. Remember, already we have defined this over here, read out, and the SV-UVM front door. Okay. And just we are updating the desired value and mirrored value variable in this, okay, using get method and get mirrored value, and printing a message that after read method, desired value and mirrored value. Let me just run this code to show you the waveform as well as the console output. Okay. I will put a link of this code in the description so that you can go through this code and you can play around with this code. After running this code, what we want, we are writing the 5 data onto the hardware register in the hardware register content, and same we are printing on the console in desired value and mirrored value. So if you analyze the wave, first let me show you the console output and then we'll analyze the waveform. Okay, so this is the output for that. After write method, okay, the write data is 5. Okay, this display we are getting from driver, and you can see the desired value and mirrored value variable will be 5, updated to 5. Okay. After read method, you will find the data read message from the driver. So read data is 5 and the desired value is 5 and mirrored value is 5, and the content which we are reading from the hardware register is there in the read out variable, in which is also 5. Let me show you the waveform over here. So if you just analyze the waveform, you can see the data in is 5. Okay, and write enable is high over here. So write enable is high, meaning we are writing onto the hardware register. So you can see the 5 data is there on this temporary range 7 down to 0. Whenever we are making this write enable signal is 0, in the next clock edge you will find the data out is 5. Okay. So this is what we are getting the desired value and mirrored value, and with the help of this write method, how we can write the specified data into the hardware register, and with the help of this front door read method we can read the data from the hardware register. And this is what the waveform for that. So you can see the temporary range register is storing a value 5 over. Okay, let me show you the interesting point over here. If we are, let's say, commenting a clock cycles, then what will happen? Let's say if we are not generating a clock over here, then it should not give anything on the output. Why? Because the front door access is require the number of clock cycles, the time it will require. Okay. Let me run this code once and we'll analyze the result on the console as well as on the waveform. So if we are not generating a clock cycles, meaning it will not give anything on the console. So if you analyze the waveform, Let me show you the console output first. You'll find it is giving a fatal error. Okay? You will find nothing is there. And if you analyze the waveform, you will find all the values are unknown because the front door access required the clocks, because we are considering the agent. Okay, and agent has that driver is requiring the clock cycles, it is waiting for that. Right? So this is what the front door access. If you analyze that result, let me show you the result. If we are uncommenting that clock generation, you'll find that it is consuming time. Okay, let me show you that also. And in the backdoor access, we'll try to explore that how it is not consuming time. Okay. If you run this code and if you analyze the console output, you'll find it will consume some number of times to store the data and to generate the result. Okay, so as you analyze over here that it is consuming some time, right? 50 time unit. It is writing the data at 50 time unit only. It is printing a message from register sequence desired and mirrored value. At 110 time unit, data is reading from the driver side. Okay, so it is consuming time over here, right? You can analyze this 50, 50, 110 and 110. If we have a look at the backdoor access, you will find, so let me show you that result with the help of PPT. So it is consuming a time whenever the data is writing onto the hardware register. While we are reading also, it is consuming some time. And this is what the waveform which already we analyzed. Now let me show you the backdoor access. So for backdoor access, actually it will not consume any number of clock cycles. So if we analyze the waveform, then only we can understand the practical practical understanding of that. Let me show you that. Before moving to that, let me show you that backdoor method. So backdoor is poke and peek. Okay, so this poke is similar to write. In this actually this poke method is used to write the value onto the DUT register. Similarly, peek is used to read the value from the DUT register. Okay, let me show you the code. It's taking some time. Okay, anyway, this is front backdoor poke and peek. Poke is equivalent to write and peek is equivalent to read. Let me show you the code. The test bench is same only. There are some changes on the register sequence and register block. So first let me explain you the register sequence, then I'll explain what is these changes, what are the changes are there in register block, because we have to provide two methods, add HDL and add HDL path slice method. So the same thing in the body, we have to define the status field, then the desired value variable and mirrored value variable. The size should be same, and the variable in which we want to read the data from hardware is. So in the backdoor write method, that is very simple. As you can see over here, the poke method is backdoor write one, right? So we have to provide the status and the value which we want to write into the hardware register. Okay. So if you see, analyze the poke method. First we are providing the register block instance dot register instance dot poke, which is the method, within parentheses the status and the value which we want to write into the hardware register. So now 10th value we want to write into the hardware register. Okay, and just we are printing the desired value and mirrored value variable using get and get mirrored value, and just we are printing a message after backdoor poke the desired value and mirrored value variable. Similarly, the backdoor peek, if you analyze over here, peek method, you will find the status and the value we have to provide in the argument, which is used to read the content of the hardware register. So peek, the status, okay, and the variable in which we want to read the value from the hardware register. So already we defined over here read out, in which we want to read the content of the hardware register. Now the desired when mirrored value variable we are updating using get and get mirrored value method. So and just we are printing a message like after backdoor peak this desired and mirrored value variable. Okay. Now let me show you the changes we have to do in the register block. So if you analyze this register block, all the things are same. Just in the build method, we have to provide the method add HDL path, add underscore HDL underscore path, and within parenthesis we have to provide in double quote the DUT, the instance with which we instantiated our design into the top level module. Let me show you that. So if you analyze this top level module, DUT is our hardware RTL code name, and this is an instance DUT through which we are instantiating our design. So this DUT we have to provide on that, okay, in the double quote. If you analyze this in double quote, we have to provide the instance with which we are instantiating our design, our hardware, right? And in double quote RTL. So these two lines we have to provide, two arguments we have to provide while we are using add HDL path. Then we have to create the instance of a register, the build method and configure, which we already know. Then here we have to provide the add HDL path slice method. So register instance dot add HDL path slice. In that we have to provide three arguments. In first double quote, the name of the register which is there in the hardware. So if you analyze, if you look at this hardware register, okay, you will find the temporary reg 0 is our register name. So that in double quote we have to provide over here. Then the second argument should be the starting bit position, which is 0 in our case, and the number of bits. Third argument is the number of bits. So 8 bits register we have. Okay, the size of a register is of 8 bits. So we have to provide two additional things over here in the build method of this register block. First one is the add HDL path method, in which two argument DUT instance, okay, and the RTL in double quote. And in add HDL path slice, the register name in double quote, the starting bit position and the size in bits, okay, number of bits, and all the things are same that create map and add register. Another interesting point over here is that right now we are not considering the auto prediction over here for backdoor. So you can make it as 0 or you just comment it out this line. Anyone is fine. If you run this code, we'll try to understand that by console and by waveform. As we are writing the 10th value 10 into the hardware register using backdoor method, so in the console we are expecting that. Okay, so anyway, it is taking some time. Let me once again run this code. If it is able to run, I will show you. Else I have the simulation result and waveform on the PPT. I will show you that also. Okay, anyway, it's not running right now. I will put a link of this with code in the description. You can go and you can play around with this code. Let me show you the result using the PPT itself. Okay, so backdoor, as we are using the poke method, right? You can see the backdoor right, that is poke. We are writing 10 value into the hardware register. So the desired value will be 10 and the mirrored value will be 10. Both will be updated, okay, with the 10. And you can analyze the interesting thing over here. The time it is consuming is 0, as I have highlighted over here, right? Similarly, while we are reading using peak method, the content of the hardware register, we'll find the desired value will be 10 and the mirrored value will be 10, and the read out content will be 10 only, because we are reading the 10 value from the hardware register, in which is also at 0 time. So this is what the backdoor access is not consuming any number of clock cycles, meaning it is not consuming anytime. Hence this backdoor access is faster compared to the front door access. You can play around with this code. Another assignment for you, that you just comment the clock, okay, in the top, and you can analyze. You will also find this waveform will be same, meaning all the things will be unknown. You will find in the waveform, but you will find the desired value and mirrored value will be updated, as we are using the backdoor access. We are using the add HDL and edge HDL path methods to update the content of the register, hardware register. Okay, so this is what the simple explanation of backdoor methods, peek and poke, and front door, write and read. In the next video, we'll try to explore about the update, mirror, predict, and randomize front door access method. Okay. So I hope you have understood that how the backdoor access is faster compared to the front door access, as it is not consuming any time to read the data and to write the data into the hardware register. Okay. So with this, I hope you have understood this concept of front door, write and read methods, backdoor, peek and poke method. And also I hope you enjoyed this video. So thanks for watching this video. Thank you.